Okay, Algebra kids, you are going to go back to IXL, but you actually will have a new login, so you need to make sure that you get the little login card. If you they should be the sub should have them. I hope that they make it to the library if that's where you're having to sit, but you need your new login, and I have recommended 7 skills that will help you practice some of the things that we've just gone over in Module 11, Lesson 1. So I've logged in as if I'm a student, and I'll just do the first couple in each one of them just to kind of show you how it looks, what to expect, and kind of just to brush up on the skills if it's something that you're like, ooh, that's kind of new, but I don't think it will be. All right, so exponents with integer bases, that is the first one in the list, and it's actually at the bottom because it's, I don't know, it's the first one. First one, second one, third one, fourth one, fifth one. I skipped 6, 7, and 11. Okay, so boom, here we go. All right, so it starts out pretty easy. 2 squared is 4. Submit. Gosh, you're so smart. 3 squared is 9. Okay, so this one probably is going to get a little bit tougher. 2 times 2 times 2 is 8. Ooh, 9 raised to the what is 10,000? Well, 10 times 10 is 100, times 10 is 1,000, times 10 again is 10,000, times 10 again is 100,000. So I'm going to say to the 5th. Submit. Well done. Okay. 3 raised to the what power is 27. 3 cubed is 27. So C has to be 3. 3 times 3 times 3. 10 raised to the what power is 100? Well, 10 times 10 is 100. So the power has to be a 2. 10 squared is 100, etc. Okay, so that's the first one. Oh, 0 raised to the 5th power. Well, that's just 0 times 0 times 0 times 0 times 0, which is 0. Okay, etc. All right, and refer to your notes to kind of help you. That's the first one. Okay. Okay, so here's the next one, exponents with actually decimal or fraction bases. So 0.02 squared, that's 0.02 times 0.02, 0.02 times 0.02. Okay, and that's going to be 0.0004. Oops, that's not a 4, that's a 7. Terrific. Okay, 0.2 times 0.2 times 0.2. Okay, 0.2 times 0.2 is going to be 0.04. 0.04 times 0.2 is going to be 0.008. Hopefully I put enough zeros. Okay, etc. All right. All right, let's look at my other recommendations. Negative exponents. Okay, which is equal to 1 over 9 to the 7th. Well, that's going to be 1 over 9 to the 7th is the same as saying 9 to the negative 1/7. Oh, sorry. Write the expression as a fraction with a positive exponent. Okay, so this is going to be 1 over, I need this now, 17 to the 84th power. Okay, remember, because something to the negative power is really just 1 over that to the positive power. Submit. Okay. 1, write the expression as a whole number with a negative exponent. Well, 1 over 42 to the 6th is the same as saying, oops, sorry, this. Hang on. Messed up. Is the same as 42 to the negative, where's my negative sign? Negative 6th. Okay. This would be 1 over 59 to the 72nd power. 1 over 59 to the 72nd power. Okay. So on and so forth. Okay, so that's the 3. Let's go back. Let's see, what else did I give you? Multiplication with exponents. Okay. J squared times j to the 4th. Well, this is j times j, and this is j times j times j times j. But if you're multiplying all of that together, that's just j to the 6th. So j to the 6th power. Submit. Okay. H to the 5th is h times h times h times h times h. I think I said that 5 times. And then h to the 4th is h times h times h times h. But if you're multiplying all that together, that's just h to the 9th power. Okay. P to the 8th times p to the 6th is just p to the 14th power. Etc. Y to the 4th times y to the 5th is y, oops, hang on, to the 9th, etc. Okay, let's see what else I have. Division with exponents, here we go. Okay, so if multiplying your exponents was basically taking the exponents and adding them together, dividing by exponents is going to be basically subtracting them. So a negative 3 on top and an 8 on bottom. That's going to be negative 3 minus this exponent. So negative 3 minus 8, and that is going to be, oh, they want it, so that would be z to the negative 11th, but z to the negative 11th is the same as 1 over z, where's z? Z to the positive 11. Okay? And the reason why I had to do it that way is because it said to express your answer using positive exponents. Okay? So this is going to be z to the negative 11, but that's really 1 over z to the positive 11. Oh, incomplete answer. Oh, let me get rid of that box. Sorry. Get rid of that. Get rid of that. Get rid of that. Okay. Submit. Brilliant. I'm brilliant. Okay. This says negative 5, and then you say minus this one. Negative 5 minus a negative 6 is really saying negative 5 plus 6, which is a positive 1. So this is just v, where's my v? V to the first power. Submit. Okay. This is negative 5 minus a negative 5. Negative 5 minus a negative, that's just like saying negative 5 plus 5 is going to be s to the 0 power. Okay, I think you guys have kind of the idea. Okay, this will be 3 minus 5. This would be w. Oh, it says, this would be w to the negative 2, which is, they want a positive exponent, which is the same as 1 over, oops, hang on. Okay, so this would be w to the negative 2, which is the same as 1 over w to the positive 2. So 1 over w to the positive 2. Okay, etc. Let's go back and see if there's any other ones that I haven't done. I think I just did this one. The power rule. Okay. Boom. Let's see. Okay. I think I'm going to remove, I think those are probably plenty. So I'm going to go back in as a teacher and just reduce this to just 3 or 4 objectives rather than 7. But anyway, you guys get the idea. That's what you're going to do. You absolutely have got to have your new login in order to do this. I will email the logins along with my lesson plans, just in case somebody, whoever's covering my classes, needs to hand them out. Okay? All right.